Welcome back, physicists, and in this video I'm going to talk to you about the horse and cart challenge problem. And we're going to be going over this in class, so you only need to worry about this video if you didn't really understand what we did in class, or if you were absent on 1/7/2021. I think in my last video I did the wrong year. Or you're watching this a different year, and it's in the future. Welcome to the future. So in this problem, we're looking at a horse pulling a cart, and the cart is accelerating forwards, and we have a mass for this, we have a mass for the horse, and we have the amount of pull force. So let's draw a force diagram for the cart to the left of the picture and for the horse to the right of the picture, and we're going to add quantitative values for as many as we can. So let's talk first about the cart. So there's always force of gravity on things, the earth, on the cart. We'll have the force of the horse on the cart. We'll have normal, because it's on the ground. And you'll have probably some sort of friction going on. And why don't these two balance? Why did I draw those ones different sizes? Because the cart is accelerating forwards, so the forwards forces need to be greater than the backwards forces. And let's look real quick at the horse. The horse is going to be having some sort of traction force forward. They will have gravity and normal, and they will have a backwards force of the cart on the horse, like what it's pulling back. And so let's think about things that we can say are equal. We know that ups and downs have to balance, but they don't balance across diagrams because they are different masses. The cart and the horse, neither of them are accelerating up or down. And because of Newton's third law, we know that the horse on the cart and the cart on the horse will also have to be equal. And next, you just have to fill in your numbers. So you can solve for force of gravity, knowing the mass on each of them, which means you could solve for also the normal, because they're equal to the force of gravity in each diagram. You know that the horse pulls on the cart with 75 newtons, which means you know that the cart pulls on the horse with 75 newtons. And so you just need to come up with reasonable numbers. So you know this one because we just went over it. You need to find possible numbers for the forward force on the horse and the friction force on the cart, and think about whether they should be 75 newtons or bigger or smaller. And Newton's third law is the Newton's third law pairs, that you have equal and opposite reactions to actions. So when the horse pulls on the cart pulls back. And Newton's first law is inertia, and that if the forces are balanced, it's not accelerating, and if the forces are unbalanced, it's accelerating. So acceleration means forces aren't balanced. Awesome. So I hope that helped explain some of it. You just have some quick things to solve for. And if you missed class, hopefully you can complete this video or this assignment based on this video. And if not, feel free to contact me for extra help.